In this tutorial video, we're going to talk about complex numbers. And to show you why we have complex numbers, we're going to take this example, x squared plus 1, and we're going to try to solve for x. So if I go through my general algebra, I do some minus 1 and minus 1, and then I get x squared equals negative 1, and then I take the square root of both sides. However, we can never take the square root of a negative number. So mathematicians came up with this new different kind of numbers called complex numbers to take care of radicals with negative numbers. And the first thing that they did is they came up with the imaginary number I to represent the square root of negative 1. So if you ever see an I anywhere inside of a formula or a function, it represents the square root of negative 1. It does represent a complex number of some kind. And with that being said, we can also say that I squared then is equal to just plain old negative 1. Because when you square a square root, they cancel each other out. So those both are very important before we go into the complex numbers. The next thing I want you to look at is in the top right hand corner. This is your standard form for any complex number. So notice that the part in blue is the real part. What that means is that it's an actual real number. So 5, 1/2, 1/4, -8. Those are all real numbers. The imaginary part is basically the real number that's attached with your imaginary negative or root of negative 1. So b should always be a real number as well, but it's connected with that I, so that's why it's called the imaginary part. So let's say I give you this. I have -5 plus the square root of -9, and I want you to write it in standard form. What we're going to do first is break apart that -9 so that it's a -1 and a positive number. So I'm going to do -5 plus the square root of 9 times the square root of -1. That is the same exact thing as the square root of -9. It's just broken apart. Now, if I simplify this a little bit farther, I know that the square root of 9 is equivalent to 3. I also know that the square root of -1 is the same thing as I. So if we check back up in the left-hand corner, let's make sure that everything is in the right place. So the first thing that should be written is the real number without the I, which I do have. I then have either a plus, and of course it could be a minus as well. But then I have my real number attached to my I. So this is my real part, this is my imaginary part, the whole thing all together over here. So we're good. That is our standard form. So let's take a look at next how to add and subtract complex numbers. So here's our problem. We're going to have 4 plus 7i plus 1 minus 6i. And it's important to understand that if you are adding anything together, that parentheses and grouping are not necessary, especially if there's no exponents and no coefficients to distribute. So with that being said, I'm going to rewrite this as 4 plus 7i plus 1 minus 6i. And what we're going to do next is combine our real number parts, which is 4 and 1, which is going to give us 5. And everything in here is positive except for that -6. So let's take a look at what we get with this combined with the -6i. And sure enough, I do get a positive 1. So I'm going to just write 5 plus I. And that is perfectly sufficient. You do not need the 1 to be written here because it's already understood to be there. So that's how we add our complex numbers. So next we're going to do 1 plus 2i minus 4 plus 2i. And unlike the addition, that minus sign is crucial to handle first. It has to be distributed before we can get rid of the parentheses. So I do this and I get 1 plus 2i minus 4 minus 2i. And now we go through the same process after our parentheses are gone. So I'm going to do my real number parts first, which is 1 plus -4, which is going to give me a -3. And when I take a look at the imaginary parts, positive 2i, negative 2i, they actually cancel out, and I have no imaginary part when I'm done. So negative 3 is my ultimate answer. So next we're going to take a look at multiplying complex numbers. And we can start with something as basic as this, where it's just 4 times a complex number. This is just your basic distribution, so I'm going to do 4 times negative 2 and then 4 times 3i. And when I do that, I get negative 8 plus 12i, and that's all there is to that. Where it gets a little trickier is if you have an entire complex number multiplied by another. So this is our foiling and distribution process. So we just have to take our time and be careful here. So I'm going to take my first term of my first binomial here, and I'm going to distribute them here and here. And that's going to give me 2 times 4, which is 8, and then 2 times positive 3i, which is positive 6i. So there's my first piece of distribution. I'm now going to take the next part, the negative I, and I'm going to distribute him here and here. So negative I times 4 is negative 4i, and negative I times positive 3i is negative 3i squared. So we have to do some simplifying here. And I've got too many things going on at the same time. I am going to go ahead and bring down my 8. I'm going to combine these two as well because they're like terms, which is going to yield a positive 2i. And now I have to break down that I squared. I squared is improper because I squared is the same thing as negative 1. So when I rewrite this, it's going to be negative 3 times negative 1. When I simplify all of this all together, I get 8 plus 2i plus 3. I now have 2 more terms I can combine, the 8 and the 3, and my ultimate answer is going to be 11 plus 2i. So that's how we're going to multiply our complex numbers. The next part is dividing, and dividing takes a couple different things to get before we actually go through the division process. What we want to look at first is a complex number, and we have something called a complex conjugate. And what complex conjugates are is you have the same exact values. So in this case, a plus bi, and then you have different signs, a minus bi. And what that allows us to do is it allows us to get rid of the imaginary parts altogether, and that's really important when we get into the dividing. So if I have 1 plus I here, its complex conjugate would be 1 minus I. And I'm going to show you what happens when we multiply these two together because this is really important. So if I go through my factoring process, or my distribution, I'm going to do 1, and I'm going to multiply that by 1, and then by negative I. Now that's going to give me 1 minus I altogether. I move on to the second term of I, and I'm going to distribute him as well. That's going to give me plus I, and then minus I squared. So when we simplify this all together, I get 1, and then notice that those i's in the middle, they actually cancel. They're the same exact coefficient with different signs. They're gone. That's exactly what I want. That's what's really important about this. There's no more imaginary parts because I squared, again, is the same thing as negative 1. So I have minus a negative 1 here, which altogether is 1 plus 1, which is equal to 2. So the reason why complex conjugates are super helpful is that it cancels out the imaginary parts. So let's go ahead and take a look at our first problem with this. So here's our quotient, and the question is going to have us write this in standard form, a plus bi. Notice that this is nothing like that. I have a complex number in the numerator and denominator, but the entire thing itself is not going to work. So the way that we do this is by multiplying this by the complex conjugate of the denominator, which is going to look like this. So in other words, you don't want any imaginary parts in the denominator at all. So of course, whatever you do to one part of your fraction, you must also do to the other part when you're multiplying, which is going to be 4 plus 2i up here as well. So to make sure that I'm doing this really carefully, I'm going to put in some parentheses so that my foiling, my distribution, works out really nice and easy. You have to be really careful in this. There's a lot of room for error. I am going to go ahead and put in one big fraction bar for myself, and I'm going to start. So the first thing I'm going to do is I'm going to grab the first part of my numerator, which is 2, and I'm going to get him distributed here and here first. So that's going to give me 8 plus 4i, and then I'm going to move on to 3i and distribute him. So 3i times 4 is 12i, and 3 times 2i is going to be 6i squared. All right, and then we're going to move on to the denominator. So here's 4, I'm going to distribute him. 4 times 4 is 16. 4 times positive 2i is positive 8i. And I'm going to then move on to my second term, negative 2i times 4. And of course, if you look here, those imaginary terms are the exact opposite of the same coefficient. They will cancel. That's exactly what I wanted to happen. Let's go ahead and do the next part. So negative 2i times positive 2i is negative 4i squared. So we're going to now take this to the next step and combine like terms and simplify. Now these guys are canceled. I can combine these two I terms in the numerator. This is going to become 8 plus 16i, and this I squared here is negative 1. Negative 1 times 6 is negative 6, so minus 6. So that's my entire numerator simplified. I'm going to do the same thing to the denominator, so that's going to be 16, and this I squared is the same thing also as negative 1. So negative 4 times negative 1 is positive 4, so plus 4. So there we go. I'm going to give myself some more space here. One more fraction bar, combine like terms. So 8 and 6, or negative 6, is positive 2 plus 16i, and then 16 plus 4 is 20. So now to get this to the very last step, to get this so that I have a plus bi, I'm going to write this as two separate fractions. This is 2 over 20 plus 16i over 20. So we just have to simplify these guys and then we're done. So 2 over 20 simplifies to 1/10, and 16 over 20, those are both divisible by 4. That's going to give me 4i over 5, and that is my standard form of that quotient. So those are your 4 operations of complex numbers, and that will conclude this tutorial.